Hello again, Year 12s. We've got our last unit for this induction week, which is standard deviation. So this is to further improve our knowledge of dispersion of data. Okay, so there's a lot going on here, and some of you might have seen this in GCSE statistics, but really this is just a measure of how spread or consistent the data is. Now there is a lot of information you do need to know, hence why you've got this graphic here. The first one, which is something that you just need to memorize, is that the mean. Okay, so this here is a normally distributed graph. Okay, now if this is normally distributed, what that means is that 68% of the data, okay, so that's quite a lot of the data actually, is within what we call one standard deviation. So a one up or one below the mean, one standard deviation above or one standard deviation below the mean. So what happens is we're going to do a calculation, and it means that it's how much it varies, how much you've got your actual variance from the mean, how much your data has a variance from the mean. The larger the range, the larger interquartile range, the larger the dispersion, the larger the standard deviation will be. Okay, to encompass the fact that 68% of the data will always be within one standard deviation of the mean. And within two standard deviations, you'll always have 95% of the data, and within three, you've got basically all 99.7 or 99.8% of the data. Okay, but the biggest point here, you use this graphic, you do need to know this. If you need to write this down or have a postcard for it, I would. Okay, let's talk about how you actually go through standard deviation. But standard deviation, remember, is just a more accurate way to measure variance or dispersion. Okay, so it shows you how spread data is. So just as an example, I don't have one written here. If I was to measure the heights of students and I found the mean to be 160 centimeters, if I had a standard deviation of 5 centimeters, that means that like 68% of my class will be between 155 centimeters to 165 centimeters. So this will be 68% of the data, because that's what one standard deviation is. So it's one above and one below the mean. So that means that I have 95% of my class will be, you should have guessed it by now, 150 centimeters to 170 centimeters, because this is two standard deviations above and below the mean, and that would be 95%. Now again, if any of this you want any clarification on, come and see me. But this is really just what standard deviation is, and then I'm going to go through actual how to calculate it, which is just a step-by-step recipe. All right. So let's look at this formula. Now there's two formulas. Just so you know, it's nice and easy, we're going to give you two formulas. So this first, and the really nice point is most tests, so all those in geography, will tell you which formula to use. So if you're calculating from the total population, so you're counting all results, your standard deviation is this formula. Now, if you're collecting a sample, the only thing that changes, you'll notice on the bottom, it has n minus 1. What this does is it helps improve your accuracy, because this is going to have a lower accuracy of the set of the population because you're picking from a sample. Okay, it just helps adjust for it. Now, all right, so what this does actually allows the fact that there might be a greater variance, and it shows a slightly greater variance for you. Now, what do all these mean? Now, we've looked at all of these symbols before, except for this symbol here, sigma, which just is used to show standard deviation. Sometimes they use S when it's a sample. All of these we've done before. We have, and it's written here, n being the number of results. x being the value, x bar being the mean. Now, you'll notice that we have this sigma. Sigma means sum of. So this actually means the sum of, and you'll notice it's the squares of the mean and the difference between the mean and the result. This is, and I'll show you how this is done in a second, but basically what we're doing is we need to sum the difference between the result and the mean for all results. Let's actually give it a go and see how we go. So we've got steps here, but let's have a look at our first question. So here is this is a table below, just shows carbon dioxide emissions in 2013, and we've got this here. What we want to be able to do is it's asked us to calculate standard deviation. So if we look at our formula, we can have a look. All right, what's our n value? Well, our n value is 10. What's the next thing we need to know? Well, we need to find out this section here, because then we need to add all of those up to be able to get this top section. Now there's a problem. If we look further into this, we need to add up the differences between the result, x, and the mean of all the data. So each of these is a result, but we don't know the mean. So before we do anything, we need to find the mean of this data. Now, if you remember, to calculate mean, we do the sum of all of these divided by 10. Okay, so when you sum all these together, you get 69.5 divided by 10. So we have a mean of 6.95. Okay, so standard deviation, remember, standard deviation is the difference from the mean. Okay, let's have a look back at that slide up, this piece up top. Look, standard deviation is how far away from the mean your data is. Keep that in mind, it's going to help you remember what we have to do next. Because we need to find out the difference from the mean for each results. Remember, the mean is 6.95. So, how far away is this from the mean? Well, it's 2.45. So what we're doing here, we're actually doing is x minus x bar. We're doing what is this result minus the mean. Okay, and we do the next one. So we do 2.5 to minus 6.95, which gives us negative 4.5. And we keep doing this for all of our results. Okay. We just find the difference of this result from the mean. Now, it doesn't matter too much about the negatives, and that's what this is for. Okay, so this is the difference from the mean of each of these results. Well, the sigma, it's the sigma of the sum of the difference of and then squared. So now we've got the difference from the mean for each result. We need to square them all, which would give us I'm just going to put it to one decimal place. Okay, so all I've done is sort of squared these numbers. Let's look. If you ever get stuck, look at your formula. It's all about learning how to read these formulas, and you'll be able to do this work. So we now have all of these here. We want to sum them. Remember, that's what this means. This means sum of the stuff next to it. So we need to add all of these up. Now, I'm just going to do this on a calculator here, of course. You don't need to see it. Okay, so I sum them all up, and I get, so the sum of all those results is equal to 375.785. Small 8.8. Okay. And last but not least, let's actually put this into this calculator. So we have the standard deviation is equal to the square root of the sum of the differences squared, which is 375.8, divided by the number of results, which is 10. Okay. Gives me a variance of 6.1. Okay, and that's it. You have a standard deviation of 6.1 here. Now, down the bottom, it asks another question. Highlight one advantage of using standard deviation instead of range. The main reason you use standard deviation is because, okay, so the main reason is because it includes all values. It's a calculation that includes all values from the data set. Unlike interquartile range, which only uses two, what the lower quartile and upper quartile is. Okay. Hope this has been insightful. I hope this helps you be able to calculate standard deviations. Again, if there's any questions, you can just come and find me. Okay.